Good morning or afternoon, depending on when you're viewing this. I wanted to go ahead and get us ready for our new section. We're in Chapter 1, Lesson 4, Powers of Monomials. Before we get started on the new topic, I want us to take a few minutes to review what we did last week. We had two main properties. We had product of powers, which basically said if we are multiplying two powers that have the same base, rather than expand everything out, we can just add the exponents together. So for example, 2 squared times 2 to the third. If we wanted to expand it out and multiply, we would have 2 times 2 for the first term, and then 2 times 2 times 2 for the second. Because again, 2 squared, that's 2 2s, 2 to the third, that's 3. And because we're multiplying these two together, notice we end up with 2 to the 5th power. While it's not too difficult to expand and multiply, it is relatively quicker to simply take the exponents from the two terms, add them together, and we get 2 to the 5th power. The reason we have this shortcut isn't for problems like this, which are relatively simple to expand, but for problems more like this, where, yes, I could take the time and do a times a times a times a times a times a. Is that 6? 1, 2, 3, 4, 5, 6? Yeah. And then I'm multiplying that with another 21. 1, 2, 3, 4, 5, 6, 7, 8. And I've already lost my patience and I don't feel like doing it. Can I? Yes. Am I going to get the right answer if I do it? Sure. But don't you guys agree that it'd be a lot faster for me to just say, okay, well, I have 6 A's from my first term, and I have another additional 21 A's for the second. Adding those two exponents together, I get a to the 27th. It's simply a shortcut. It doesn't mean we can't expand it out. It just means that we don't have to if we don't want to spend that kind of time. For problems like this, one thing I want to remind you guys of is an exponent only belongs to the term directly next to it if they're not in parentheses. So for example, this, if I were to expand it, would be a 4 followed by 4 R's. And then I have a -4 and 3 R's. All of this is multiplication. So I can reorganize my problem to where my 4's are next to each other, the 4 times -4, and then all the R's. And we can see here that I have a total of 7 R's. That would leave me with -16 R to the 7th. If I didn't want to expand it and instead wanted to use the shortcut, again, I can just reorganize it to where my numbers go out front, 4 times -4, and then I have, for the base that's in common, R is the common base, I just add the exponents together. Notice we get the same result. The other property we looked at was quotient of powers, and this stated that if we have two powers that have the same base that we're dividing, we simply can subtract the exponents. Not subtract the bases, not anything like that, just the exponents. So again, if I were to expand and cancel this out, 2 to the 7th would be 1, 2, 3, 4, 5, 6, 7 on top, and 1, 2, 3, 4 on the bottom. And as we know from division, if I have the same number in the numerator and denominator, they cancel each other out. So those twos cancel out, those cancel out, these cancel out, these cancel out, and notice I'm left with 3 2's, or 2 to the 3rd power. The shortcut is for me to simply subtract the exponents. And notice we always take the numerator's exponent and subtract the denominator's exponent. It gives me the same answer. Can you always expand it out? Of course you can, but you do not have to. And it saves us time for problems like this where I don't want to type all that out or write it all out. Instead, I can just do 18 minus 7. That's x to the 11th. And when we do have numbers involved, again, this is division. It doesn't mean I subtract them.